Now, at this exact second, AI companies are literally burning through $500 million every single month on data centers, not on marketing, not on salaries, on the physical machines that train and run artificial intelligence. And here's what blows most people's minds. That number just keeps going up. By the end of this video, you're going to understand exactly why these companies are willing to spend that kind of money. And spoiler alert, it's not because they're bad at math. So let me ask you something. When you use ChatGPT or Claude or any AI tool, what do you think is actually happening behind the scenes? Most people assume it's just magic. A computer thinks, a response appears, done. But that's not even close to what's really going on. Every single time you type a prompt into an AI tool, that request gets sent to a server somewhere. And not just any server. We're talking about specialized hardware called GPUs and TPUs. These aren't like your laptop's processor. They're designed specifically to handle mathematical operations at insane speeds. Think of a regular CPU like a really fast reader who reads one book at a time, incredibly quickly. A GPU is more like a stadium full of readers, all reading different books simultaneously. They're parallel machines. And AI absolutely needs that. When you ask an AI a question, it's not thinking like you think. What it's actually doing is running your question through a neural network. That's a mathematical model with billions, sometimes hundreds of billions, of parameters. Every parameter is a number that's been learned from training data. So every response requires running trillions of mathematical operations. And that happens on data center hardware. Thousands of GPUs working in parallel, all coordinated perfectly. Here's where the $500 million a month starts making sense. First, GPUs are expensive. A single top-tier GPU like an NVIDIA H100 costs around $40,000. Some estimates put them higher. And major AI companies aren't buying dozens of these. They're buying tens of thousands. OpenAI alone is estimated to have over 25,000 GPUs. Google has hundreds of thousands. You do the math. That's literally billions of dollars just in hardware. But it's not just the GPUs. You need the physical building, climate control. These machines generate insane amounts of heat. We're talking about cooling systems that rival industrial facilities, power infrastructure, networking equipment to connect everything, security, real estate. And then there's power consumption itself. A single data center running AI models can consume as much electricity as a small city. Some estimates suggest training a large language model uses as much power as 1,300 US homes use in a year. And electricity isn't cheap, especially when you're running 24/7. So you're looking at millions per month just in power bills. Now here's something most people don't realize. There's a massive difference between training an AI model and actually running it for users. Training is the expensive part. That's when the model learns from massive amounts of data. OpenAI reportedly spent over $100 million just training GPT-4. That's a one-time cost, but it's enormous. But running the model for users? That's the ongoing cost. Every time someone uses ChatGPT, servers are firing up, GPUs are calculating, data is flowing. Multiply that by millions of daily users. And you're running inference, that's the technical term, across enormous infrastructure. And here's what makes this brutal. Inference isn't cheap. Some estimates suggest it costs anywhere from a fraction of a cent to several cents per request. When you have millions of users making thousands of requests per second, that adds up faster than you'd think. So the $500 million a month? That's training new models, running existing models at scale, maintaining redundancy for reliability, and building for future growth. You might be wondering, if it costs this much, why do AI companies keep expanding? Why not just stop? Because scale is the only way these companies survive long-term. The more users you have, the more data you collect. The more data you have, the better your models become. The better your models, the more users want to use them. It's a flywheel, but you have to keep feeding it with money and hardware. And there's competition. OpenAI isn't the only player anymore. Google has Gemini, Meta has Llama, Microsoft is investing billions. Every company is racing to build the next generation of models. And that means buying more hardware faster than anyone else. The data center build-out is literally a race. Whoever has the most computational power can train bigger models faster. And bigger models tend to be better. So why should you care about $500 million data center bills? Because it's the economic reality behind the free tools you're using. ChatGPT might be free to use, but it's not free to run. Every response has a real hardware cost. That's sustainable when you're monetizing through subscriptions, API access, or enterprise deals. But it also means that not every AI tool will survive. Companies with weaker funding or less efficient infrastructure will struggle. The landscape is consolidating toward the players who can afford the massive data center investments. It also explains why data center demand is skyrocketing, why electricity grids are struggling, why NVIDIA's stock went through the roof, why cloud computing providers like AWS and Google Cloud are expanding like crazy. Everything connects back to the fundamental question: how much hardware can you deploy, and how efficiently can you use it? Here's what you need to remember. The AI boom isn't just a software story. It's an infrastructure story. It's physics. It's power consumption. It's real buildings with real hardware running real calculations. And it costs real money. A lot of it. The $500 million a month? That's just the beginning. As models get larger and more users come online, that number will climb. If you want to dig deeper into how AI actually works under the hood or explore some of the tools these companies are building, I've linked everything in the description below. And if this stuff fascinates you, the hidden economics of technology, how things actually work behind the scenes, hit subscribe. We break down the real story behind the tech everyone's talking about. Thanks for watching. See you in the next one.